Hi, I'm Haripriya Kumaraswamy. This will be an introduction demonstration of my research project. I have tried my best to cover all necessary details of the research. The research is about music signal processing in a very high level. There are many projects involved with music in many aspects. Genre classification is one of them. I have taken Indian classical music to examine the genre. So there are two Indian classical music. One is Hindustani music and another one is Carnatic music. Carnatic music, which can be also called as South Indian music, is a very wide area to examine. There are thing called Raaga. Raaga acts like the genre of the Carnatic music. So without Raaga, there is no Carnatic music. I had narrowed down the theme from genre classification into Indian classical music, into Carnatic music, into Raaga. So Raaga is like the backbone of Carnatic music, which is a melodic framework. There are 72 parent ragas and more than 34,000 permuted ragas from the parent ragas just within Carnatic music. There are even more ragas in Hindustani music as well. So all these ragas are made up of 5 to 7 notes only. There are no such products to in form of software or solution system available in the market till now. It would take an average person 10 to 15 years of experience to expertise in the area of finding the raga manually. So the scope of finding this raga has been even more narrowed down into polyphonic music. The term polyphony is the simultaneous combination of two or more tones or melodic lines. There is also another type of music called monophony, which has only one texture of melody. But in this case, Carnatic music is always been polyphonic because it involves with more than 5 or 6 instruments, different instruments, and sometimes involves with more vocal tones also. So these texture type increase the challenge task to computerize. So considering all these facts, the aim of this project is to design, develop, test and evaluate a software solution that will identify raga in Carnatic music. So the research gap identified is polyphonic music, because the existing projects focus more on monophonic music and not much with polyphonic. From a few projects that have been done regarding polyphonic category, there were so many issues like variations around notes and manually derived fundamental frequency. Apart from detecting the fundamental frequency from monophonic, no projects have focused detecting tonic independent and fundamental frequency automatically in polyphonic music. Out of various research articles which were taken into consideration, taken through a thorough literature review, more than a half research articles have mentioned polyphonic music as limitations and future work. So lack of projects in this field makes the project even more narrowed down. This table clearly shows the reason why there are only a few projects in this area. So changing nature of music, changing impulse, undetermined and noisy part are some nature of Carnatic music feature. When it involves with more instruments and all, this will be anyways challenging even more enough. The solution is derived from this concept map, and this concept map was used to identify the research idea, research area, research gap, and even the techniques and which technologies that I should come up with, and which is a novel area and all. This component inside this red box is the system, and all other boxes are the components related to it. Taking this Indian classical music, which is divided into Hindustani music and Carnatic music, as I mentioned already. With Carnatic music, there were only few articles found, so I have chosen this area to explore more. There I got its possible researches such as tonic detection, music recommendation, song name identification, motif recognition, note detection, singer identification, beat identification, and all. The most suitable project related to data science was the raga recognition. So there out of thousands raga, I have taken only 3 ragas called Abogi, Mohanam and Kalyani to explore. With much limited researchers, novel technology, polyphonic music, which were some limitations, so that have been taken into account. The aim of this certain project is not increasing the accuracy or the performance, but to explore a whole new area with the domain part and even the technology part as well. Seeing the map to technologies, the solution of the problem could be achieved by using supervised learning or unsupervised machine learning. I've gone for supervised machine learning because I had the data set labeled, and supervised learning suits this system more perfect as the problem involves with classification problem. So Gaussian mixture models is the machine learning algorithm chosen to work with. I didn't go for deep learning or other things because there were no existing models or pre-trained models that I could use. A design diagram of system feature flow is shown here to explain in high level what happens within the proposed system. The dataset will be divided into training and testing. These Carnatic song will be pre-processed, noise cancelled, converted to waveform format by the system so that the Python can work with it. The features of the music audio will get extracted in the feature extraction step here. So these features will be trained using Gaussian mixture model trainer, and Gaussian mixture models will get generated. The Gaussian mixture model predictor will compare a test song input and return the genre by doing a majority voting. So with the help of this high-level architecture diagram, the proposed solution can be explained well. The high-level architecture of this system is three-tiered, where tiers will separate each layers to act individual and connect. So this architecture diagram consists of three layers. The system consists of three layers such as presentation layer, logic tier, data tier. So this presentation layers displays the UI, where user will be uploading an audio as an entry point. While the process happens in the logic layer, the system will be shown as processing in the UI for the users. So there are features like uploading MP3. Uploading MP3 is where a UI related to initiate the system uploading MP3 for Raaga prediction. And then the processing audio will be shown in the presentation layer to users. Then the users can also see the display Raaga displayed. This is like the final stage in UI to display the Raaga after processing. The system starts with the data tier. Data tier is where the machine learning data set will be stored and fetched for data prediction. The training data will be used to train and make models following components and steps from logic tier. Training data set is the audio set that will be used for training. So logic layer is where all logic algorithms conditions are contained. This manipulates and make it the functionalities required. Temporary storage of data model files which will be replaced after each training will be saved in this layer. The whole systems from developer's perspective is depicted by the diagram. And research contribution part lays in the logic tier, where all the pre-processing, feature extraction and model comparison takes place. This is where the setup engines, algorithm generator, pre-processing generator, task display lays. So the audio files to be trained will be fetched from the data tier, and all the system process will take place to identify the Raaga. So there are like 5 components in the logic tier itself. The data pickle generator is used to change the audio format to Python readable format to start the training. Dataset trainer, this will be used to train the models. Feature extraction is features of the music will be extracted for both training set and for the new audio user inputs. MFCC involves in the feature extraction technique, that is like the main algorithm. And the secondary algorithm is used for the classification is GMM models. This will be used to train models using machine learning. So this is the user flow of the proposed system solution. Here the user will be able to redirect the web application and the home page will get displayed. He or she will be able to input an audio file. This has got input validations where he cannot input an audio file, that is input a file which is not an audio, and the user cannot input an audio which exceeds 10 minutes duration. A processing bar will get displayed to show the user that the system is working on the processing detection. After the system returns a value, user will be able to give a positive or negative feedback to the system, and finally it will take the user to the home page where he or she can upload another music to check the Raaga. This UI flow will give an overall idea on how this system works. I will take it to the backend demonstration after this. So this is the developed system, and I'm demonstrating this from a user's perspective. So if I give an unsupported audio file, for an example, if I give a PNG file like this will give a response from the system, media not supported. If I give a lengthy audio file that exceeds more than 10 minutes, the system will process. And I'm getting an error from the system as response. So I'm giving a correct audio file, mp3 file. If I inspect this, so here the system accepts this and starts to do the detection processing. While inspecting this, this is showing the client to server connectivity. So here we can see that the system has accepted the input file from the user, and this also has returned the response. So we can check for the processed outcome in the response bar, which is displayed here. So this is passed. After taking a feedback from the user, the system will redirect it to the home page where the user can add another file to get the Raaga predicted. So this is the code-based platform where the core functionalities of the system has been taken place. This is the application file where the Flask API configuration is defined, and also the port number is also defined. Port location is defined here, and audio extraction file. This is the file where the extraction of features have been taken place. The mp3 to waveform conversion has been taken place here using the library called audio segment, and also the duration length of audio file validation has also been written in this space using this, and the delta values are converted. The delta values of songs will be calculated with this particular method, and the method is written to extract mfcc feature vectors is here, and the user input files will be saved by default as test, this particular thing in this folder, and this will get replaced every time the user inputs. is formed combining each folders. So the data set that will be sent to the training part, training models will placed here in these separate folders. So I have created 3 folders for 3 ragams, and all these are all the data will be, audio files will be placed here in order to take. The models will get generated in this folder, and these models will also get replaced right after each running the train file each time. So this is the train raga.python file where Gaussian mixture model is used to use here to train these models with the help of the pickle files, which is used to serialize and deserialize a Python object structure. The files are readable and writable. So for every pass of the files, these pickle files are helping. And by the usage of MFCC and GMM together, the system was able to achieve a target of prediction raga. So this is the prediction class where the user input raga features will get compared to the model files. Gaussian mixture model will take the highest matching label from the comparison list, and the raga label will get returned. So Gaussian mixture model will be used to calculate the scores of the features for all models. The Raaga model with maximum score is considered maximum in the sense high score is considered as the predicted raga is at the end. This is the model accuracy class. So this helps to generate the confusion metrics and give an output for the measures and scores in a tabular format. This is where the accuracy gets calculated and the success of the system can be derived. This basically compares the numeric values of predicted versus the actual labels and all. So for the front-end part, React.js has been used, which is a JavaScript library to build the interface. A simple component class has been created to display the return input data using rendering method. Other than those, stateful components and the components using external plugin have also been used. The application is built all together, combining all components using props and states from here, and the event handlers are rendered inline, and event delegation was used to collect and implement. Grommet, which is a tidy package, a React-based web framework, was used to design the UI to provide the accessibility and the theme like Netflix. The evaluation of the project. While checking for the user functional requirements, evaluation on functional requirements, all these 12 points have been achieved. Cross-checking, admin will be able to train the audio set with relevant Raaga classes. System will be able to predict Raaga for polyphonic Carnatic music. Library should be able to replace and save models with newly trained models. And program should be running in computer as virtual server. User should be able to upload MP3 file by selecting browse option. User should be able to drag and drop functionality. Able to use the drag and drop functionality, upload an audio file, and the system will be able to accept MP3 files from the user and convert it to WAV format. System should be also able to accept only audio files from the user. User can only upload an audio file of duration less than 10 minutes. Real-time genre classification has been done. User will be able to navigate home to upload new music to get the Raaga predicted. And finally, the user will be able to give a system feedback. All these requirements are gathered from the requirement engineering by doing a quantitative analysis from end users, domain experts, and other technical experts. And while checking for the evaluation of non-functional requirements, these points are also achieved, but some points are partially achieved. like coming from the beginning, the GUI should be user friendly so that anyone can access easily. Duration to process and retrieve the classified Raaga should be within 1 minute. That has been also achieved. Process system should be accurate when generating the types for Raagas. This one is partially achieved because there is only the accuracy in 57. We cannot get 100% accurate, but with the data set replacement we may increase the accuracy, and since this is a novel technique, the accuracy is very normal. 57% is very normal. So system should not get slowed when the training data set gets increased. That one is also achieved, but this is regarding the performance. And the system should be compatible with any browser, since this is a web based application. Yes, that is also achieved. System should have a documentation for both users and developers, and system should be able to reuse its components according to requirement changes. System will be able to work in any platforms and operations without having to make vast changes in order to make the code work. The future enhancements of the project. Since this is a web application, this can be later turned into mobile application, and with a good collection of data set, the accuracy can get increased, and the labels of the data from 3 to many can also get increased, and this shall be deployed as a proper system. And with an availability of split from DSA, which is an open source project source code, this is used to do the audio separation and all. When trying this to polyphonic music, this can separate the vocal and instruments, and I have actually tried a couple of times already to extract vocal from polyphonic music, but the data set I was having some issues. This can be furthermore developed with split after collecting fine audios. This will for sure increase the accuracy and lead the process to an extreme success. And usage of Gaussian mixture models with deep learning methods will also lead to a vast success, giving a good prediction. And then we can introduce algorithm to identify the instruments being played in the track, and the singer identification also we can put as features. And then we can also use refined algorithms to do pre-processing and all. So that is all. Thank you.